This is section 3.5, and we're going to deal with transformations of given graphs. And before we talk about the transformations, we need to make sure that we know the shape of the basic graphs. And some of them you know pretty well probably, and others maybe not so much. But let's look at them. So y equals x squared. Most of us know that's a parabola, and the basic one has its vertex at the origin. Y equals square root of x starts at the origin, goes to the right like this. Absolute value of x has a vertex at the origin. It's a v like this. X cubed, or a cubic equation, looks like a drain pipe and crosses and changes direction at the origin. So those are the four main ones that we will use. Now let's talk about vertical shifts in a graph. So if you have y equals f of x, and f of x could be any of these four, plus k, or f of x minus k, that shifts the graph. So if it's positive, it goes up k units. If it's negative, it goes down k units. So here's a quick way to remember: plus, up, minus, down. So here's a picture illustrating that. We've got your basic x squared here, and then this is x squared plus 4, the vertex shifted up 4, and x squared minus 5, the vertex shifted down 5. So there's all three showing that they're based on this x squared basic. That's a vertical shift. Now a horizontal shift moves right or left, and the difference is now we've got f of x minus h or f of x plus h. There's parentheses. This didn't. The k was added at the end. This is inside the parentheses. Now, if it is minus, it goes to the right. If it's plus, it goes to the left. So here is y equals square root of x. That's the red one. And then y equals the square root of x minus 2. That's going to go to the right 2 and then start. The square root of x plus 4 is going to go to the left 4 and go that way. Or here's the one with x squared. X squared is the red one. X plus 3 squared, it went to the left. And x minus 2 squared went to the right. So horizontal shifts go left or right, verticals up and down. Reflections, the only one that we're going to be really concerned about is the reflection over the x-axis. And that's when, like, you have a y equals x squared, but if you have y equals negative x squared, it flips over the x-axis and goes upside down. It could be the same way with the absolute value of x or negative absolute value of x. The last one we've got is when you have a number in front of f of x. So here's your basic x squared. If you have 3x squared, a number bigger than 1, it's going to make it skinnier. It's going to be narrower. So there's 3x squared. Anything that's a fraction under 1 makes it wider. So here's 0.5x squared. So we'll be looking for those transformations of our basic 4 graphs in the problem set. So let's go look at our problems. All right, let's see how these are worded. So several of these say the graph is a translation of one of the basic functions, and it lists all 4. Find the equation that defines the function. So we recognize this is a square root. And what did it do? It went down 5, if you can see that there, and to the right 2. So the right 2 means that inside the square root, we've got x minus 2, and outside, for the vertical, we've got a minus 5. On this one, we're still at the square root function. It went left 1 and up 5. So that's the square root of x plus 1 and then a plus 5. Find an equation that shifts with these parameters. Shifts right 2 and down 5, and our basic is the x squared. So right 2 means we have a minus 2 inside the parentheses, and we have a minus 5 outside. So that would be this one. And in this graph, the dark one, and you can probably see it probably colored on the computer, the dark one is the basic x squared, and then the other one is where it's moved. And so we're looking for going to the right 2 and down 5, and it would be this one. All right, on number 4. So this one has the basic format doesn't look like what we've been having. We haven't had it look like this. So we've got x squared minus 4x plus 1 that moves left 2 and up 5. Well, you need to remember, left affects every x in the equation, up affects the constant. So everywhere that there's an x, we now want to have x plus 2. So x plus 2 squared minus 4 times x plus 2 plus, we have a 1, and then we need another 5. So 1 plus 5. So that's going to be a 6. So that is what we're looking for here. So that's how you do it. You just have to remember these statements here. And then it says graph the original and the shifted graph. Well, here's what I suggest you do in your calculator. Put the original in y1. So put this one in y1. And then, sorry, this is the original. Put that in y1. It wouldn't matter if you did it backwards, but put that one in y1, put this one in y2, and you'll get one of these graphs. And it happens to be this one. So I think that's what you need to do for that. Number 5, write a formula for this function that shifted up 1. That means we're going to add 1 at the end. Negative 3 plus 1 is negative 2. So you end up with this as your equation. Number 6, absolute value of x, but it goes left 2 and up 8. So the 2 is positive inside the bars, and then we have a plus 8. Number 7, square root of x goes to the right 5 and is reflected about the x-axis. So this means there's a minus in front. This means we have a x minus 5 inside. So here we go. We got that. Number 8, graph f of x plus 3. So the dash is f of x. We don't know what that is, but we know that. And if it's plus 3, we know it's going up 3 from where it is. So that's this one here. All right. So to do the graphing tool, we have to do a couple of things. So we have x minus 3 squared minus 1. So we have a horizontal shift and a vertical shift. When you get your original thing, it'll say click to enlarge graph. Go ahead and do that. And then this is a quadratic, so we'll go here and choose the quadratic tool and click on the origin. When you click on the origin, this palette will come up. So in this palette, you do have the vertical shift here and the horizontal shift here. So this was an example that I did for this equation here. So if we have an x minus 3, then that's a positive 3 for the horizontal shift. So you would have a positive 3 there. You do have a negative 1 for the vertical shift that would put there. And then you close that and it will move your graph, and you'll check to make sure it's right. But you have to do these things, and just remember, if it's negative in here, then over here in the palette it'll be positive. If it's positive here, it'll be negative in the palette. All right, number 10, sketch the graph of the function. The absolute value of x plus 4. So you want a v that's going up 4. This one went down, this left, this right. So it's definitely this one. Here, square root of x and then plus 1. So you're looking for the one that just starts up 1 unit, and it's right here. 12, square root of x minus 2, so that's to the right 2, and then up 4. So here we go, right 2, up 4. All right, and our last one is another using the transformation and the graphing tool, 1/5 x. All right, so enlarge the graph and choose the absolute value tool, which is this, V. So you'll choose that. You'll click on the origin, and it will tell you up here to click on another point. So in this one, it was 1/5 x. I let x be 5, and so 1/5 of 5 is 1. That meant x is 5, y is 1. And so you would plot, you have your V here, and then you would go and plot 5 and up 1. You click that, and it would create the right shape of the V. So follow that idea, pick an X value, plug it in, and get a Y value. And I think that really covers the transformations. That should not take you too long. Most of those go pretty quickly. So that'll end up finishing chapter 3.